We received a question about Math 3A at UCLA, differential calculus. Here's our video response.
You show me that this equation has a solution. You go ahead and use the intermediate value theorem. Okay? So the idea is going to be, I want to use the intermediate value theorem. I want to know that this equation has a solution, right? But a lot of times this is kind of tricky to work with. So if you want to simplify things, I don't want to bring everything to one side, so it might be easier to look at. So is everybody okay with this? Because this is the same thing, right? Exactly the same equation. Okay? The other thing is, for the intermediate value theorem, you want to plug in values and get an answer. This is kind of weird because if you pick x, you're not free to pick what x is. If you pick some x's in here, it might give you 0. If you pick different x's, it might not give you 0, right? So what I really want is a general flexible equation. So I could write this equation, right? So I make up my function, where my function doesn't have to be 0. My function is you plug anything in and we just compute this number. Okay? No big deal. So I've got a function here. Okay, but can you find an x such that when you plug the x into this equation, you will get 0? If that's true, then we've solved this problem. Okay. So let's see if that works. Let's try the intermediate value theorem. So remember what the intermediate value theorem says. The intermediate value theorem says is if it looks something like this, and you have some points down here, A and B, and you're looking for some magic height here, right? Let's call that y. The intermediate value theorem guarantees you, as long as you're continuous, you can find some guy in here, I don't know who he is, but he exists, such that when you plug c into your equation, f of c is y. Okay, so let's try this out. So here's my equation. It's continuous. Trig functions are continuous. Well, some guys are continuous, some guys are not. In this case, cosine is continuous everywhere, right? This guy x is obviously continuous everywhere, so this should be a continuous function. No big deal. So I'm guaranteed the continuous part. They don't give me an a and b, so I need to make one up. Okay? But remember what your goal is. You want to find some value of x, so you want to find some value such that when you plug it in, you hit the magic number. And the magic number for us is going to be 0. So what I really want is, I want to know, is there a c such that when you plug that c in, f of c is 0. Okay? Where c is that value you're plugging in for x. Okay, so let's try this out. First I need to benchmark it. Let's just pick easy numbers. So I think if I pick an easy number, why don't we pick 0? 0 is an easy number, right? So let's start an interval at 0. Okay? And then what I'm going to do is I'm going to test this out. So when x is 0, what do you get? You get cosine of 0 minus 0. But that is what? That's 1 minus 0, so that's 1. Okay, so when this function is 0, again, if we thought about it, we could probably see what this looks like. I don't even want to do that. I just want to have some generic function, and I want to start over at 0. Okay? Just draw this line. I'll pretend like I'm at 0. And I know at 0, the height is something like 1. Okay, no big deal. Now I need to find another value. But remember what you're trying to do. With the intermediate value theorem, you're trying to get somebody that ends up landing at 0. So if I want to land at a height of 0, I need a number here probably bigger than 0, and a number here smaller than 0. I've already got my number bigger than 0. Right? So that's my 1 up here, height-wise. Okay, now I need to get a value lower than 0, or smaller. And we can try, sine function looks like this. Right? And you remember that once we go over, let's say pi, yeah, we can do that. Once we're down to pi, or even pi over 2, it's fine, either one. I'm going to go ahead and go to pi. So if you move over pi, right, the value is -1. Okay, so let's try that. So I'm going to try this again. I'm going to plug in cosine of pi minus pi is equal to what? You don't even have to compute an answer. Because cosine of pi, if you look in this picture, is -1. And -1 minus pi is definitely a negative number. That's all I need. So now what I've got height-wise is I've got on my picture, there's some height of 1, then there's some height of, I think, a negative number. So that means somewhere over here it's negative. I don't even need to know what that number is. And I got some picture. I don't even need to know what that picture looks like. Let's just pretend it looks like that. Okay? So, then we're going to clean this up. What did you plug in to get your 1? Well, we plugged in 0, right? When we plugged in 0, we got a final answer of 1. What did you plug in to get your negative number? Well, we plugged in pi, right? So pi is over here. Okay, so our values are 0 to pi gets me a number that's 1 to something negative. Okay, then I'll use the intermediate value theorem. So the intermediate value theorem says since, so first get your interval, so you have 0 up to pi. Is it true that this function is continuous from 0 to pi? Sure, it's continuous everywhere. No big deal. Okay, then I need to pick a value. So I wanted, let's say we have f of 1 is equal to, or I'm sorry, f of 0 is equal to 1. So 0 gives me 1. F of pi gives me some negative number. F of pi gives me a negative number, right? So if I pick any, the intermediate value theorem says, if you want any height in between, you can get that. Okay? So by the intermediate value theorem, since these facts are true, so I'll point that out, right? We have what? Y, and y, our target y was 0. So by intermediate value theorem, since you have some negative number is less than 0, and 0 is less than 1, right? So you got the number trapped in between. There exists a C such that, so there's some C out there, I don't even know who he is, or who she is, whatever. There's some C value such that when you plug it in, plug him in, f of C is equal to 0. Okay? But now you're done. Because now you know there's some C that will give you 0. Some C gives you 0, so you plug that C in, the answer would be 0, which means this equation works, which means this equation works, which means there's a solution for this equation. Okay? And in this case, that solution would be C. Okay, so that's one way to use the intermediate value theorem.
See, wasn't that easy?